A very good morning to dear children. Welcome to physics online classes. Before I begin my class today, I would like to put before you some why questions that would answer today's topic. Why does it hurt when you're hit by a cork ball, and why doesn't it hurt when you're hit by a ordinary TT ball? You're not hurt, but by cork ball you are hurt. And why does a truck in motion can even run over you and kill you, even at a very slow speed? But when a truck is at rest, it doesn't hurt you. Even if you go and hit, you are not that much hurt. And why does a small bullet of very little mass, you can carry the bullet, but it can kill you? How is it? How the bullet can kill us even though it has very little mass? Three questions. Let us think. And to answer these three questions, we enter into today's class Newton's second law of motion. Yes, we are into the today's topic Newton's second law. Before I go into Newton's second law, I would like to give a quick recap of Newton's first law of motion of the last class. What we have done in the last class, we have done balanced and unbalanced forces and Newton's first law of motion and what is mass and inertia. In a balanced system, an object doesn't move at all. It is a highly balanced system. When an object moves, then we can say there is an unbalance in the system. Only the unbalanced system causes the object to move. Unbalanced system is the first condition for movement. After that, what is the first law of motion? Hope you remember. And what is Newton's first law of motion? A body continues to be in the state of rest or in the state of motion unless otherwise an external unbalanced force is applied to it. It will be in the state of rest. I have explained in a detailed way. Hope you have understood all those important topics about Newton's first law of motion. And after that, we're done with frictional force. Frictional force is the opposite force to the applied force, frictional force. If you are moving anything, if you are walking, if you are just pushing, always there is a frictional force. Even the friction is even the friction can be produced by the air friction can make the ball to stop, and there is a ground friction on the surface. So the force that acts opposite to a applied force and it stops, it makes the object to reduce the speed and velocity, that is frictional force. And inertia, I gave wonderful examples for inertia. I am giving a quick recap. Inertia depends on the mass of the subject, mass of the object. I said subject, mass of the object. When there is a high mass, more inertia. What is inertia? Inertia is the resistance. It is the laziness. It is a tendency offered by the object to be in the particular state. If it is in the state of rest, it wants to be in the state of rest. If it is in the state of motion, it wants to be in the state of motion. It doesn't want to be get disturbed. That is inertia. If the inertia, if the mass is more, the inertia is more. I gave four examples. When you are in a car, when you are in the movement, riding in the car, when the driver applies a certain brake, we move forward because our body wants to be in the state of rest, but the vehicle is trying to come into rest, but our body wants to be in the state of motion. And another very good example I gave is in the when we have a good right turn or left turn or a steep curve, we tend to move on the other side. But why? It is because of inertia, I said. And another important thing, when you're standing in a bus, you immediately when it stops, you move backward because bus moves forward. It is in the state of rest to motion, a change of state. Nobody wants the change of state. So we resist. That resistance is called inertia. So I have given enough examples for that. Now, actually, we are getting into today's topic. And before I begin today's topic, there are only 26 students who have done the Google Forms. I was a bit disappointed. Out of 47 students, only there are 5 to 6 questions. And the two, if you follow with the video, you follow again and again. If you don't understand, you watch it again. You may not understand on the first watch. You watch it once or twice or thrice, and if you doubt any particular point, you watch it once or twice so that you understand. That's my point. So there were very less number of students who have done the Google Forms, but anyway, my sincere appreciations and congratulations to all the students who have done very well, who have participated, who have done the Google Forms, and who have got 10 out of 10. They are really great. Arokya, Santana, Shirley, Karen, Catherine, Aditya, and Siddharth have done very well. They have scored 10 out of 10. Hats up to you guys. You are doing well. Great. It's really encouraging that you are doing well and I can do more for you. If you're not doing well, I will lose the interest of doing the classes for you. Thank you. And the second place and the third place, I will let you know during the course of this class. Now, we are coming into Newton's second law of motion. Newton's second law of motion. Now, we have come from the beginning. We are not jumping into any new thing. We come from position, movement, distance, displacement, speed, velocity, everything in the first unit. From there we have come what causes this movement. Okay, the force causes this movement. So in this unit we are studying about force and the laws of motion. In the first uh, law we did what causes motion? The force causes motion. Unless otherwise, the body will be in the state of rest. Will be in the state of rest. Nobody can do anything for it. Now, coming into the second law, this force causes change in velocity. This force causes change in velocity. What is this change in velocity? You remember? You should know now. The change in velocity is called acceleration. This force causes, I hope I'm not giving this force causes change in velocity. This change in velocity is called acceleration. When you give more force, the body will accelerate at higher speed. When you give less the body will accelerate at slow speed. So force can change the acceleration of the object. So we are going to deal with the second law. Now I am coming to those questions. They have given three different questions. What are they? Did you think over it, ponder over it? First one. If you are hit by an ordinary TT ball, you are not hurt. But if you are hurt by a cork ball or a rubber ball or stumper ball, if you are hit, it is paining. It hurts. Why does it so? Because TT ball has less mass, but the cork ball has high mass, highly dense. First point. An empty truck. Okay, the truck, when it is at rest, if you go and hit, you will not hurt much. Okay, if you are walking and going and hitting on the truck at rest, doesn't hurt you. But if you go and hit a truck which is in motion, even if it is moving at a very slow speed, it will hurt. It will kill you even. Why? It is in motion. That's an important point. And the last example I gave is the bullet. Bullet, you see, the size of the bullet is less than this. The mass is like that. Mass may be quite greater than this. But it can kill you. Why? Why? Why it can kill you? But a chalk can, doesn't kill you because that bullet is highly dense, even if it is in a small size, but it hits with greater velocity when it is triggered by the gun. The bullet moves at very high velocity and it hits you. So, in all the three examples, something comes to our mind. What is that? That is mass. That is mass and velocity. Yep. If it is of high mass, that will hurt. If it is of high velocity, that will hurt. So there is some component which has both mass and velocity, and Newton names that component as momentum. Momentum. He calls that as momentum. Momentum is the product of mass into velocity. This momentum has direction and magnitude. So, if a quantity that has direction and magnitude, what's that quantity? Is it a scalar quantity? No, it's a vector quantity. So, the direction is in the direction of the velocity. So, that is called momentum. Momentum is a product of mass and velocity. This is a very important point you should know in this law. Actually, the law comes, the Newton's second law of force comes from this momentum. So it is a product of mass and velocity. This mass and velocity combines to form a momentum. So what would be the unit of momentum? Mass is, the unit of mass is kilogram, and what is the unit of velocity is velocity in meter per second. So the unit of momentum is kilogram meter per second. Force also, now we are coming into the point. we have understood what is momentum, and when we apply to the second law of motion, this force causes change in momentum, not momentum. The force, all the more we are doing about this force. This force, in the first law we said this force causes motion. This force stops the motion. In the second law we say this force causes change in momentum. Change in momentum. How? Yes, we will do now. To understand the change in momentum, I will give you some good examples. You see, now this is a box of 5 kg. Initially, at this position, this box is at rest. Now, we are moving this box at time t seconds. Okay, maybe 5 seconds or 2 seconds. In time t seconds, the box is moved, it is given an unbalanced force. If the unbalanced force is applied on this box, automatically moves. Initially, it is at the state of rest, so the velocity is 0. And finally, it attains the velocity 10 meter per second. See, final velocity is 10 meter per second. Now, this is case 2. This is case 1. Case 2, the same box, it at the same position with the initial velocity as 0 at rest, and now I am moving this box to 20 meter per second. Final velocity is 20 meter per second. First initial velocity is 10 meter per second. Second is final velocity is 20 meter per second. Now, obviously you can say where I need more force. The first case or the second case? Obviously, it is the second case because I need more force to move this particular box to attain higher velocity. So higher velocity means, yeah, there is a change in velocity from 0 to 20. Now it is 0 to 10. The change is less. So the force, the applied force is less. Yeah, is equal to the applied force is less because the change in momentum, the change in velocity is less, so the applied force is less. Here, the change in velocity is more. It attains 20 meter per second. Ultimately, the force is more. Okay. The change in velocity is called acceleration. So when there is a change in momentum, ultimately the force, there is a force, there is an increase in force. To understand this concept, I would like to give you an example like a car. A car, it's not moving because there is a battery failure. The engine cannot start by the initial starting motor. Now they are trying to push the car. When they try to push the car, immediately when we try to push a car and the car attains 1 meter per second speed, it can pick up. But when they move for quite a time, it increases its acceleration because there is a change in velocity. You are moving. Now the velocity is increasing. When the velocity is increasing, there is a change in velocity. When there is a change in velocity, there is acceleration. When there is acceleration, there is a change in momentum. Ultimately, the car gains its speed. Okay. Now, this change of momentum. This is an important point I said. Change of momentum. is directly proportional to magnitude. What is magnitude? Magnitude is the value. It's a quantity. Magnitude of the force into time taken. It is the time taken. In a particular time, you are applying the force, so there is change in momentum. You should not confuse with the momentum and force. This change in momentum is force. So what is momentum? Momentum is a product of mass into velocity that I said in the beginning. From momentum, we are coming to force. Force is this change in momentum. To understand this concept, for the change in momentum, the force is change in momentum. They have given a very good example in the book. That example is catching a ball. Catching a ball. I hope many of you, quite many, even not only boys, even girls. I hope Chetana is a cricket player in our class, and now she knows how it is to catch a ball. Now, catching a ball is a very good example of change in momentum. For example, somebody hits a ball. Somebody hits a ball, the ball is coming at some velocity. Ball is coming at some velocity. Now, when you catch the ball like this, immediately, you're not doing anything like that. You're catching the ball like this. When you catch a ball like this, what does it happen? Now, the moving ball comes to rest. State of motion, state of rest. When it comes to rest immediately, now what is the rate of change of velocity is zero. It comes to rest immediately. When it comes to rest immediately, what does it happen? The rate of change, it does not increase, the rate of change, the time is zero. In this time, just below my hand, when the ball just reaches below my hand, and when it reaches my hand, the time is very less. So when the time is very less, when the time is very less, you know, immediately it comes to rest. Immediately it comes to rest. What does it happen? The force will increase because the rate of change of momentum appears at a moment. So a high force, a heavy force is applied on my palm, it will hurt. But when you see cricket very closely, but when you play cricket also, when somebody catches the ball, they will pull it back. Why do they pull it back? When they are hit by a, when the ball is hit by a very strong force, they try to pull it back. Why? Because ball is at the state of motion. It doesn't. They don't want to put the ball immediately at rest. Okay, like this. Because if you do that, it will increase the force that is applied on your hand. But when you pull it, you are making the ball to move in this direction by your hand. It is also in the state of motion, so that it will come to rest gradually. This is the point. This is the point. The point is when we increase the time by doing it slowly, when you make it come to rest, there will be less change in momentum because velocity gradually, because you're catching, velocity gradually comes to rest, not like this. When the velocity gradually comes to rest, the zero position, there is less change in momentum. When there is less change in momentum, there is less force. But if you don't change the position, when it comes immediately to rest, when you catch the ball like this, you're not moving your hand. Less change in momentum, greater change in momentum, greater force on the hand. This is called change in momentum, that is applicable to Newton's second law. This rate of change of momentum that is directly proportional to the applied unbalanced force. This applied unbalanced force causes rate of change of momentum. That is in a particular time. Here the time comes. When the force comes, the time comes. But in the momentum, there is no time. But when it comes to force, there is time. It is not the change of momentum. It is the rate of change of momentum. Rate of change means with respect to time. Okay. One another example I can give you. Um, you are holding now. I cannot give you a demonstration because that is not possible. You are having imagine that this mouse or is a glass tumbler. Okay, glass tumbler. This is a, when I put it down, what does it happen? If it is a glass tumbler, when it hits on the ground, what does it happen? Immediately it breaks, right? When it hits on the ground, it breaks. Why does it break? Law of second law of motion, rate of change of momentum. How does it break? Because nobody is applying force. Is there any unbalanced force? You see, when it comes with, it has some mass, it comes with velocity, ultimately there is momentum. When it's about to hit the ground, it doesn't hit the ground, it has mass and velocity and momentum. Right? Mass, velocity and momentum. But at the moment it hits, immediately it comes to rest, right? Immediately it comes to rest. So where does that energy go? So it comes with mass and velocity, it touches the ground, immediately the rate of change of momentum, the mass, the velocity comes to zero. When velocity comes to zero, from some point, from some value, it comes to zero. So there is immediate change at a very short period of time. Now, what does it affect? Force is applied from the ground so that it breaks. So that it breaks. High force, rate of change of momentum is less. Because time is less. At the point it hits, immediately comes to rest. Immediately rate of change of momentum is zero. Immediately high force. But a very good example is when you put the same on the pillow or on the bed, does it break? It doesn't break. The glass doesn't break. Why? It is because when you put, when it hits on the bed or a pillow, not that it's not a rough surface. It will go. It will when it touches the pillow. If it is this is a glass ball. Imagine it's not a glass. It's a glass tumbler. Imagine when it hits the pillow or bed. Now it is not in this position. It's not a concrete. It goes and comes because it is a pillow. It is a bed. This surface can go down and come. So, in that time, the rate of change of momentum is not this particular glass is not immediately comes to rest when it comes. For example, when it touches, I can put it like this. When it touches, it comes down. Okay, when it touches the bed, it comes down. So it doesn't come to rest immediately, but it takes some time. This jerk is there, no? Okay, like that while they're catching, there is a movement. So here also there is a movement. Slowly it comes to rest, not immediately. So the rate of change of momentum is delayed. When it is delayed, ultimately the force is less. When the force is less, there is no braking. Okay, I have I have explained enough and more. What is the rate of change of momentum? Now, Newton's second law. Newton's second law is this. Rate rate of change of momentum is directly proportional to the applied unbalanced force. Applied unbalanced force in the direction of the force. Okay, this is important. The rate of change of momentum is directly proportional to the applied unbalanced force. Unbalanced force. Rate of change of momentum. It's not change of momentum. So because rate of change means in a particular time. Now you have known what is the importance of time in the rate of change of momentum. I said when you're pulling, you're increasing the time. You're not making to come to rest immediately. You're but when it falls on the bed or the pillow, it increases the time to come to rest. That is rate of change of momentum. Now the mathematical formula. Mathematical formula is damn easy. How to understand this mathematical formula? Imagine object of mass m. The initial velocity is u. You know that. The final velocity is v. Of an uniformly accelerated motion. Then after the application of force, that comes time t. Okay. The mass m, initial velocity u, final velocity v, application of force in the time t. Now you know what is momentum. I have said momentum p1, initial condition. What is momentum? Mass into velocity, m into v. Instead of v, what is initial velocity? So we can write u. What is the final velocity? Final momentum into is equal to m into v. Okay, m into v. V is the final velocity. U is the initial velocity. What is the rate of change of velocity? Rate of change of velocity is change of momentum. Change of momentum is p2 minus p1. That means m v minus m u. That is m into v minus u. Now, this is change of momentum. Change of momentum means p2 minus p1. Initial, final minus initial. What is the rate of change of momentum? This rate of change of momentum means we give the importance to t time. So when I write rate of change of momentum, then I will write t with a particular time. Now this force, and you see this. Now, this force is directly proportional to the rate of change of momentum. So, yeah, when this rate of change of momentum, that comes yeah. Can you see that? Okay. Yeah is equal to m m m is directly proportional to m into minus u divided by t. You remember what is this v minus u divided by t? V minus u is change in velocity with respect to time. What is change in velocity with respect to time? That is acceleration. Acceleration is a change in velocity. So f is proportional to m into a. So to remove this proportionality, we put some constant. Okay, f is equal to k. K is a proportionality constant. Huh? K into m into a. If k is 1, f is equal to m a. This is Newton's second law. F is equal to ma. So, what is ma? M is mass of the object and a is acceleration. Ma means how much unbalanced force is applied. The force, what is 1 Newton? So, unit of force, we can say, what is m? The unit of m is kilogram. What is the unit of a? Unit of acceleration is meter per second square. So, kilogram meter per second square is called Newton. We can say kilogram meter per second or Newton. So the unit of force is called Newton. So when do we count it is 1 Newton? Simply you apply 1 for all those things, that is called 1 Newton. F is equal to ma. When we call this as 1 Newton, 1 Newton, 1 kilogram of force. So the force that is needed to move 1 kilogram of any object to 1 meter per second square acceleration. When you move 1 kilogram of mass to 1 meter per second square acceleration, then that is called 1 Newton. You put everything 1, that's all. That is the force required, that is equal to 1 Newton. Okay? Hope you have understood what I have said. And catching the ball and breaking up the glass is a very good example of Newton's second law of motion. And what is the fun if you don't solve any problems? Okay, here comes some of the problems, very easy problems because we have only two formulas. One is P is equal to mass into velocity, the momentum, and F is equal to M into A. That's all. Only two formulas. I will not do all the problems right now. I will give only two problems, but I will give some problems in Google Forms. Find the momentum if the mass and speed and velocity are one and the same numerically. So simple. What is momentum? P is equal to mass into velocity. Okay. Mass is 400 grams. Is it SI unit? Gram is an SI unit? No, it is not. Kilogram is an SI unit. So convert into kilogram into 10 to the power minus 3. So 0.4. 0.4 kilogram into what is velocity? 20. That gives the value 8 kilogram meter per second. That is momentum. P is equal to 8. So this is one problem I can give. Very damn easy problem. Nothing is there to solve. And there are some problems that I can give is F is equal to find out the force if they give mass and acceleration. Okay, this is one formula, this is another formula for Newton's second law of motion. This is the second problem I'm going to solve. This is in the book, maybe exercise 9.1. Do all those exercises. Do all those exercises in a note, and I will give you something in the Google Classroom. Only 20 students have entered into the classroom. I will give you the code. You remember the code? You remember those code? JMNQ7Q4. JMNQ7Q4. I have given you the request. Today also I will give you the link to enter into the classroom. There I give some assignments. Okay. Google Forms is not enough because the exams are coming. You have to train yourself. Fine. Now this is a question, very easy question. This mass is 5 kilograms. The initial velocity is 3 meter per second. So the mass with the velocity is moving. What is the force that has to be applied? If the force that is applied for 2 seconds, it will reach the final velocity at 7 meter per second. So 3 meter per second, it's moving at 3 meter per second. Some force is applied. It's moving to 7 meter per second. What is the force applied? Okay, then easy. The formula F is equal to M into A. What is this A? This A is nothing but V minus U divided by E. Change in velocity with respect to time. What is the mass? 5. Change in velocity 7 minus 3 is 4 in 2 seconds. 2. Okay. When you cancel it, 10. 10 Newton. Newton is the unit of force. 10 Newton. Now, the second question is, if the same 10 Newton is applied for another 5 seconds, okay, 5 seconds, what will be the final velocity? You see, everything is there in the formula, nothing is new. If the same 10 Newton is applied, what would be the final velocity? Apply the same formula. What is F? 10 Newton is applied to the, for example, what is the mass? Mass is 5 kilogram. V minus U, what is the final velocity? We don't know. Okay. Initial velocity 3 divided by 5. Right? In 5 seconds, you check the problem in the book. Very easy problem. Okay. Cancel, cancel. Now 5 will be cancelled. When minus 3 comes on that side, plus 3. 30 is equal to 30 meter per second. So V is equal to 13 meter per second. That is the final velocity. Yeah. So I hope I have given. I will give some problems in the Google Forms also. Hope this point is clear to you. What is momentum? The product of mass into velocity. What is force? It is a rate of change of momentum. I have given you the examples. Hope you have understood that. In the next class, we will go and we will understand Newton's third law. That's very interesting and fascinating law that applies in our day-to-day life. In our day-to-day life, whenever you see the things, you open your eyes and see with the eyes of physics. So everything will be insight for you, and everything will give lot of meaning to you. When you see everything with the idea of physics, with the eyes of physics, how it moves, how it comes to rest, how it stops, how it moves very fast or maybe very slow, whatever it is. So you understand those things very easily. Hope the class is interesting and fascinating to you. We shall meet in the Zoom class today. I hope you will all come. You should come so that we shall clarify the things. I can say whatever, but whatever the doubts that comes to your mind, keep it, write it down, pen it down. And when you come to Zoom class, you ask all those doubts. The class is only for clarification. It's not for a lecture like this. It's for clarification. Many doubts, you ask many number of doubts. Okay. And so you get more clarification. more understanding of the fundamental concepts in physics. Thank you. Let us meet on the next class. Goodbye. All the best. I'm sorry, I forgot to say the topics of the last Google Forms. 9 out of 10 is got by Vikrant. Good Vikrant, appreciate you. And 8 out of 10 is secured by our Nityanandan and SS Lokesh. Very many congratulations to both of you. You have done well. I'm happy about that, and it gives me more interest to do more for you. Thank you. Bye.